Hello everyone, welcome back to my channel. And this video is going to be very interesting because in this video I am going to show you how to build this 7 segment display encoder. This encoder will take 4-bit inputs, will output different values for 7 segment display to show different digits. For example, if I mm, provide 0011 inputs, and then it will show 3, which is the decimal value of 0011 binary value. So let's get started. Before showing you how to build 7 segment display, if you don't know, this is a simple 7 segment display. We can name each segment A, B, C, D, E, F, G, and then we can control each segment to display different numbers. For example, to represent or show 0, we need to turn on all the segment except G, and for 1 we need to turn on B and C, and for 2 we need to turn off F and C, and for 8 all the segments should be turned on. As it is a single digit display, we can only show values from 0 to 9. So these are the binary values that will provide as an input to show decimal values. For example, to show 3, when the input will be 000, it will turn on all the segment except G. But for now we will only focus on the segment A to build a logic gate that will control how when the segment A will be turned on. For now we will ignore the parts where segment A is turned off, for example where its value is 0. As you can see from the table, when the input will be 001 or 0100, the segment will be turned off, and for now we will ignore these values. We will only focus on the values where this segment needed to be turned on. So we can create an expression before building logic gate. And to build an expression, we have to connect all these inputs with AND gate for all these combination from 0 to 9. For example, as you can see, A, B, C, D, and you will see a bar above it. Bar represent the not gate. So the single section like A, B, C, D bar, this should out 1 because all these inputs will be connected by AND gate. That's why we needed to convert all the input to 1 to get 1 as a output. That's why we have to add a bar which is a NOT gate where the value of input is 0. As a second example, you can see the C input does not have a bar, but all the inputs have a bar because the binary input 0010C is already outputting one value, but all the other output inputs are 0. That's why we need to add NOT gate. This plus sign represent we needed to connect all these gates with OR gate. But the issue is that this expression is still very complex, and as you can see, this is for a segment A, and if we do this for all the segment, connect logic gates using this expression for all the segments, we have to spend a lot of time. We can actually simplify this equation, but I have added a page in the description where all the values for segment A, B, C, D are already simplified using K-map, which you can visit. So now let's build the logic gates from those values. So this is a circuit for segment A, and we have to repeat this for all the segments. Then we have to connect all these designs together to get our final circuit. We can actually add all these logic gates in a single circuit, but that will make this project very complex. So I think it's better to create logic gates or circuit for each segment and then connect that circuit together to control the whole display like this. In this circuit, as you can see, each segment is receiving the same for input from the input pin and providing its output to the each segment of the display. For example, the circuit for segment A will only control the A by using the inputs of the circuit. Now we can test this circuit using the binary inputs, but it's a lot fun if we use the 4-bit adder from the previous project and test it using these display. As you can see, I think it's a lot more satisfying to see its result than the last video which I did, in which the output of 4-bit adder was in binary format. So that's it for this video. Let me know if you have any question.